Welcome to Everyday Asphalt. My name is Jim Warren. I would like to welcome everybody to the show today. The purpose of this program is to go a little bit deeper in areas of materials, design, construction, and maintenance. We post all these programs on our YouTube site. If you go to YouTube and just type in Everyday Asphalt, it should come up. Or it's also on the Texas Asphalt Pavement Association website and also on the Apex website, the Asphalt Pavement Exchange website, which is where this program lives now. We also post these on audio versions of it, so you can your Spotify, Apple Podcast, any of the audio platforms. You should be able to find it by just going to Everyday Asphalt and hooking us up. This is we are in our third year. I think this is episode 37 or maybe 38. I'm not sure exactly, but we've been kicking along here. Again, every third Thursday of the month at 3:00, these broadcast. And if you watch it online on the third Thursday and you register for that, you can register for that at texasasphalt.org and click under the events and click under Everyday Asphalt. You can register. If you register, you'll actually get a PDF for it for 1 hour for the session. So you can put that, if you're a professional, you can use that for your annual updates, etc. So glad to have everybody here. Today we got Dale Rand. Glad to have you, buddy.
Good to be here, Jim.
It's exciting to have you here. We talked about a month or so ago about some ideas and some materials. One of the many committee meetings that TxAPA has, and we're talking about stuff, and you gave some kind of insights, and I was like, oh, we got to tape this. We got to get this down for history. So we're really glad to have you here.
Right. Thanks.
But as we kind of get started, let's I always forget to start my clock. Let's just kind of go back a little bit of history of Dale Rand for everybody who knows you and who hasn't forgotten you yet or whatever. So let's go back to the beginning, how you got started.
Okay, well, I was raised out in Odessa, so Midland, Odessa area, out in the oil field, and kind of got my start really in the industry as in Odessa, I worked summers for a rental tool company, overhauling drilling equipment and all of that. And when I got the chance to go to work for TxDOT, there was an area office there, and a friend of mine, actually Robert Lee, was working for TxDOT, going to be a summer employee for TxDOT, and he said, "Yeah, they're."
Oh, no kidding!
So that's
where you guys met,
right? Yeah.
Wow.
Yeah, we met. Well, we met at actually Odessa Junior College at probably taking calculus class at night or something like that. But then I found out Robert was going to go to work for TxDOT, and so he told me about it. So I applied for a summer job with TxDOT. So I worked 2 years in the Odessa area office, maybe the 83, 84 time frame, and then. Went off to school at Texas Tech and graduated in 1987. And
the Red Raider?
Yep. Red Raider, yeah. And then after graduated, I went to work. So the area engineer, Bill Burnett, at the time from Odessa, became the district engineer in Abilene. So I got a job in Abilene. My first full-time job was in Abilene area office for TxDOT. So from 87 to 89, I worked there in the Abilene area office, and then transferred in 1989 to the Materials and Test Division.
Okay.
And I was pretty well in Austin area materials and tests most of that time, from 89 till 1999. And then 1999, I actually went to work for TxAPA for 1 year as a technical director.
That's right.
Because at that time, a little background is Magsud Tomarasi was my boss there at TxDOT. Magsud was only 4 years older than me and smarter than me, and so I thought, I'm never gonna
get that job.
I've moved up as far as I'm going to go with TxDOT with Magsud here, so I went to work for TxAPA, and then about a year later, Magsud started Pavetex Engineering in 2000, and so I ended up going back to TxDOT and taking Magsud's old job, which was over the flexible pavements section there in the Materials and Test Division, or back then we called it Materials and Test, then it became part of the Construction Division. So. Was there till 2013 as a director of the Flexible Pavements branch.
Wow, okay. Long time.
Retired in June of 2013, so I had about 26 and a half years total with TxDOT, and then went to work for Magsud, who at Pavetex Engineering, so he'd been in business then 13 years. So I moved down to Dripping Springs and went to work in the consulting world for Magsud 2013, and was there till 2023.
Yeah, about 10. Yeah, okay.
Yeah,
All
so
right.
about 10 years there, and got the chance to become the executive director of the Lime Association in 2023, and so I've been there about 2.5 years. So,
Wow,
so
what a broad spectrum.
yeah, so
That's cool. That's cool. So you were in TxDOT some very formative years in specification development and changes and a lot of the material stuff. A lot of stuff going on then, right?
right, yeah, that actually started in Abilene. So Bill Burnett was actually kind of one of the early pioneers of the QCQA specifications. He was a pretty innovative guy. And so in Abilene, in fact, the first job I ever worked on was an interstate rehab project, and as an inspector, training under another inspector out there on the interstate. And we were doing what they called then end result spec. It was a brand new spec, and we were trying this thing where the contractor was responsible for doing the design and the testing and all of that. So there was kind of the very infant stages, and I want to say that would have been probably 87, 88 time frame where we were doing. We didn't call it QCQA then, but it was end result. But that was kind of the beginning of what became QCQA specifications. And then when I transferred over to the construction division in '89, then that was a lot of that development towards QCQA specifications was going on then. Yes.
Okay. Wow, that's cool.
Yeah.
You know, I think a lot of folks that have not been around a long time or come into the business, and even in the last 20 years. At one point, TxDOT did all the designs. They set the plants up. They set controls, and the contractor basically just kind of ran the materials. And for most of the country, that's how that was. And then this whole evolution of stuff. Now, Texas was really early in the process. You might have been one of the first ones, if I remember correctly, that really kind of got into this whole idea of this QCQA specification process. So you were involved in the actual development of it, right?
I was involved in some of the early. It was really Mug Sood, Tom Ressi, Ken Fultz, and some of those guys. Paul Kruger, I think they were all in there. So I was there at the time, just a young engineer. I didn't get my license until 1993, and I think that's about the time that first specification came along. So actually, interesting fact is I was one of in the first level 1A certification
I was going to say,
class.
were you one of the?
I was number 6. Yeah.
Wow.
So in the first, very first class, and then then I lost my certification when I went back to get my master's degree because I was gone for 2 years for a while and I let my certifications lapse. So I went back and got it, but I was no longer number 6. But I was original number 6. So
one of the first dirty dozen, huh?
Yeah.
That's funny. Yeah, because that was 93, so that's a long time now for that whole program. So it really is. Texas. I've been around a while too, and that was one of the. I remember I was like, "Oh, look what they're doing." And so it's cool. Good job.
Yeah, I get a kind of interesting background going back to the Abilene days. Though, you were talking about so. I think that early on, the contractor only just showed up with supply the equipment and produced the materials. So TxDOT ran the plant, ran the paving operation, and even in 1987, the guy that trained me as the chief inspector would jump up on the paver and start turning the crank and making adjustments to the paver and all of that. So this was the Tex guy really almost operating the paver.
Wow.
Now, the contractor had their own operator, but they were very hands-on with it, not like it is today. I wouldn't. TxDOT typically wouldn't do that, but back then they said, well, the original contracts were, hey, the contractor just shows up with the equipment, and we'll tell them
what to do,
how wide,
how
deep,
to
do it. Yeah,
how fast.
Yeah,
how fast we're going to run, how number truck. Yeah, it's been that was I think really kind of very formative. Fundamental transformation in the whole industry when all that stuff started happening is because you went from, TxDOT actually had to back off, and the contractors had to step up. So that period of time where there was that transition probably had some growing pains, shall we say?
A lot of growing pains,
in that on both sides.
Right.
And so I imagine that was pretty interesting to be part of. In the process, kind of looking back, compare that to where it is now. And actually, there's really a fundamental shift where the industry, industry meaning the contracting industry, et cetera, really have probably most of the knowledge on that area.
Right, yeah.
And TxDOT is doesn't. But I mean, that was the decision. So is what it is. So it's good. It's good. So the early '90s are when the new specification came in, and I know, were you involved in the specification development at all, or was that kind of on the peripheral?
I was in the background of that. I wasn't
Okay.
one of the primary authors of that
Yeah.
one. The 2004 spec book I was very involved with, and the
Right.
next in the
14?
in the 14, yeah,
Okay, okay.
that was the two main ones that I was
Okay.
highly involved in. Chaired the spec rewrite on
Okay.
the item 300s, but yeah, I was
People don't
in
realize.
I was on the committees developing it
Yeah.
early on, but I wasn't.
But
the
so
main.
you saw the process.
Yeah, yeah.
And those are probably very interesting. I've been involved in that. I was involved in that in Florida when they redid theirs,
Yeah.
and it can be pretty brutal at times because you're really moving you're blowing the cheese up. I mean, from
Yeah.
that perspective, and there's I remember some pretty interesting discussions, shall we say?
Yeah, it was a big
in
paradigm
this.
shift. But
Yes.
yeah, and I think we all kind of know. I think just intuitive back then, and for people that don't know why we even went to QCQA
Yeah.
specifications, it was like you said. TxDOT told the contractor everything to do, how much asphalt to put in this, which aggregate, which exactly. So we told them exactly how to build the cake. Say make us a cake and make it this way, and then ultimately you say we don't like that cake. And so the contractor would say, don't tell me exactly how to build
Yeah.
how to bake this cake.
Right, method
You tell
spec.
me
Right.
the method spec.
Yeah.
You don't tell me exactly how to do it, and then tell me you don't like it because we did exactly what you told us to do. And
Yeah. So
the
that kinda
shift from
shifted that
whose
whole-
responsibility really should it be, who has control over the materials, and all of that was really on the contractor side. And so that's
Well, I mean,
the evolution of
kind of
that, so.
evolution. So it is,
Yeah,
it's kind
so-
of one of those interesting, particularly when you run into some of the people who've been around
Yeah.
a while,
Yeah.
and they still remember that.
yeah.
And some of the contractors, the older contractors, they were involved in that too. And it's like, yeah, it's really, really
Yeah.
fundamentally different than it used to be. So,
Right,
okay, so you went through the QCQA spec, and that entailed actually setting up the HMAC and all the certification
Right.
trainings. That was a huge lift
Right.
for TxDOT and the whole industry. And so, if you again think back, we were talking about that earlier. It's like you're trying to remember what y'all did at some at specific times. What other things did you see, kind of going through the process in those maybe the '90s or something? What else came on board from TxDOT perspective once we kind of made that shift?
There was a bunch of things happening then, actually.
Okay.
So it's good. It's a really good question because, so not only were we shifting from QCQA, but Superpave, all
Yep.
the Superpave stuff in the mid '90s was
Yep.
coming along.
Yep.
So when I first transferred to Materials and Test Division, we did what we call the VMA
Yep.
design procedure, I actually had the privilege of reading some of the original papers. We had original papers from Francis Veeam, who was the guy in California that developed that methodology. But Texas was a VEAM state, so we ran a lot of VEAM stabilities, and so
Yep.
and it's funny even today when, and as a consultant, when someone calls me and says, "Do you know how to run the HVEAM test or the HVEAM test?" I was like, "Okay, this guy hasn't been around very
been
long."
around a while.
So,
You're
but I
new.
used to get a lot of those calls.
Sure.
Hey, do y'all run HVEAM tests?
Yeah.
But so we ran, so back then, I mean, a typical day in the Materials and Test Division was we got buckets of the 1 gallon buckets, and they had 3 specimens that were molded pucks, and we ran VEAM stability on those
All day.
200 or 300 a day. So we had
Whoa.
55-gallon trash cans there that our guys would test it, throw them in the trash. So we were basically just a VEAM factory there.
Just crunching them out. You must have had a
So-
lot of oven space.
So we did, yeah. But that was a big part of what we did then. We were a full-time testing lab, and I'd say probably 80% of what we did was running VEAM stability they shipped by bus from all over the districts.
The districts weren't running them at that
No,
time?
the districts didn't run it
So
at all.
everything
at that
came
time.
through
Yeah,
Materials and
it
Test.
all
Wow.
ran Materials and Test. And
Holy cow.
Yeah, good.
Wow.
Yeah, so it was so we were shifting from that, and then so the QCQA started coming along, and then the whole design procedure we were looking at was, okay, now how do we go from beam stability? And then all the research was towards Superpave. And so then a little bit further into the 90s, we were doing QCQA and transitioning into the early Superpave. And then
Wow,
SMA came
holy
along.
cow, yep.
Some of the new mixes came along
Yep.
there. So there was a lot of changes at that time. So, but I think what we were dealing with back then, probably, you know, early on, when I first started my career, the biggest problem we had nationwide and statewide was rutting. I
Yeah.
mean, everybody talked about rutting. So if you went to a conference, everything was
Everything
about
was
rutting.
rutting.
How do we
Yep.
solve rutting problems?
Rutting this, rutting that. Yep.
And then we had stripping problems. And so you'd see rutting and stripping a lot of times were together, where you saw, well, is this a rutting problem or is it a stripping problem? We would see issues with pavement failures along that line. So the old Lotman test was the one that we used for moisture susceptibility. And
Yep.
so I got involved real early on. In fact, that was my probably first exposure to lime was in the early 90s. And
Sure.
it was about that time around 93 or so that Tom Scullion and Magsud and a bunch of people were doing research on this Northeast Texas hot mix. And so they did a big study on, I think it was probably Lufkin, Paris, Atlanta district, and one other one in the Northeast Texas, looking at the Lotman test and the effects of lime and liquid antistrips on it. And that was my first exposure really to lime, and, flashback,
Sure.
number of years later as I'm working for the Lime Association. But that's the first time I saw that, this is how lime really affects these
Right.
things. And so
Right.
there's a research report out there on
Yeah.
Northeast Texas that was done that
Yeah.
really showed, the effects of lime. So
Yeah,
that
you're
kinda
right.
got
I
me
mean,
into
that just wasn't Texas at the time. That was across the country.
Right, yeah.
Those we think things are local in many
Right,
cases, but in many cases when issues come up, they're not local. They're global issues, and just every state kind of figures out how to make it work in their own state. And
Right,
so
yeah.
Texas had, Lotman, lime, those kinds of things, and other people were doing different things, and that evolved over time. And so asphalt is not static.
Right.
It's sitting here on the tabletop, but it is anything but static. Over when you look back, every 5 to 10 years, there's some pretty significant kind of
Yeah.
changes.
Yeah.
Or improvements. I mean, it's getting better every time. It's pretty damn good material now, but it has evolved quite a bit. So, well, it's neat. So, wow, you have been through a lot in that area. So you went through kind of lime and Lotman, and so and then Superpave implementation, and Superpave was kind of like late. It started kind of in the early 90s, and then kind of went through and really kind of got done around, I believe, around 96-ish,
Yeah.
97-ish, in that range. I was involved with some stuff on a national level at that point with it. But then what happened? What happened after that? You're still with TxDOT at this point in time, right?
Right, yeah. So going back to, and ultimately, so really what we were working on trying to solve then, the biggest issues was how do we solve rutting and stripping issues was the biggest problem that we had at the time. But going back a little bit, let me touch on one thing on
Sure.
because I know you and I have talked before about the VMA issue.
Yeah,
So
yeah.
we got started on that in
Voids in the mineral aggregate.
So-
Are you going to define what it is?
Yeah, I will. I'll talk about
Okay,
VMA because
all
a
right.
lot of people don't know what VMA
All right,
is.
let's talk
So
about
I think the background on this for at least at TxDOT is we were wanting to. So there was a couple of things. I mentioned that rutting and stripping was a big issue, but the other issue we knew we were getting some really dry mixes at
Yeah.
times, and so
So you got both sides.
both sides of it,
Yeah.
yeah. So we would. So we wanted to put into the specifications some minimum asphalt content, to say, okay, for type D mix, you had to have at least X%, because we were seeing some jobs where, were really, really low asphalt content, raveling and things like that would start occurring. And
Yeah.
so VMA basically, so there was a lot of pushback on, hey, you can't really, don't tell us how much asphalt to put in it. That's
Now we're getting back to that method spec kind of
right,
deal.
the method
Sorta.
spec, and the fact is, there's a lot of, with different absorption and different aggregates across the state, it was really hard to come up with one number to say, okay, this
Absolutely.
is,
Limestone's got to be this.
Limestone's
Granite's
much
gotta
more
be this,
absorptive than-
Sandstone's got to be this.
Right.
What if I got a mix? now what do I
Yeah.
do? And so it really is kind of when you're setting a number for that.
Yeah.
It's huge. It's
So
huge.
really what VMA is, for folks that may be out there that don't know, is VMA is just the volume of, instead of weight, if you take the specific gravity, just weight over volume. So rather than specifying weight, we went the back door and said, okay, we'll specify it by volume. VMA is just basically the volume of asphalt. Really, the unabsorbed asphalt technically is what it is.
Correct.
The unabsorbed asphalt and the air voids in the mix. So it's a way of specifying the quantity of asphalt. Both of them were specifying the quantity of asphalt. And so we were trying to adopt a VMA specification at that time to work that in with the 93 spec book. And I'm trying to remember, I think in the 93 spec book was probably the first one that actually had VMA mentioned in there. So.
Okay. So again, how that came about, because it's the same kind of discussion today, is whether I'm going to use a limestone material which has absorption. They can absorb, probably 0.5%, maybe even more, to an igneous material, or a granite or something like that, which is basically or a gravel that's basically got no absorption.
Right. Yeah.
We're still having some of the conversation. So I'd kind of like to go back to why TxDOT set the value and the properties that we're measuring or not measuring, because, to do it fundamentally, like say, per the MS2 Asphalt Institute version, you would measure the aggregate gravities and measure absorption, and there's a whole bunch of calculations we're not going to go through today in order to do that. But Texas didn't do that way. So I want to kind of talk through that a little bit, because that's where I think maybe some people have some questions about why we're doing something, but it's important to understand the background on that. So can we back up on that and just talk briefly about that?
Yeah, because it's pretty important, because a lot of people, so Texas is probably the only one that calculates VMA the way that we do it. And I'll get a little bit of background on it, because in Texas, we use the rise specific gravity to back calculate, to calculate VMA, which really takes into account the absorbed asphalt plus the air voids. So our VMA numbers technically will be higher than any other state. So the more absorptive the aggregate is, technically you can get more asphalt into that. So that we count that absorbed asphalt, which is technically 100% incorrect. So anybody from academia and all that will say Texas does it wrong. Y'all been doing it wrong. And so some of the reasons why we kind of acknowledge that we do it wrong is the reason that we got to that point was in the early 90s we started trying to implement a VMA specification. At that time there was no certification on how everybody run all these tests, how you run bulk specific gravity. So the VMA,
which can be a little bit, there's some points where it's a little bit tricky at a couple spots.
Yeah.
And that can impact the values, and that's why.
Yeah. So what we did back then, we actually sent out samples to all the districts and said, everybody, here's the aggregates and calculate the VMA. And so all the district labs across the state, they all did it and came back, and we sent out a proficiency sample that we were expecting a VMA of 15, and we got numbers from 11 to 22 or something like that. It was all over the place. And so we went into looking at why are we getting such a big difference? We can't implement a specification if we can't all run the test the same way.
Correct.
So we had VMA schools back then. So we brought everybody in and said, this is how you run the aggregate specific gravity. And so
here's the fine, how you run the fine. Here's the course, the little tamping thing, do all that sort of stuff.
Right. And so the issue with that is there's some subjectivity into what is determined as SSD.
Absolutely.
When I draw an aggregate back and say this is at SSD, and you draw it back and you get it at SSD, that really affects absorption and affects the bulk specific, the gravity of those aggregates, those numbers. And so depending on how you run the test, and there is a good deal of subjectivity to it.
Even the fine aggregate one too.
And the fine aggregate affected it more than others.
Yeah, the angularity of the material, the texture of the material, that can all impact.
Right. Yeah.
You're trying to get the right moisture content, so this little thing slumps when you pull the cone off. But if it's rounded material is going to operate differently than angular material. So it's not as easy as people think it is.
Right. And so we went through probably, I'm going to say, a year or two of doing research and doing these training schools and training everybody to do it. And then So part of it it's almost like, and this was, again, before we had certification, there wasn't Ag 101 certification or whatever.
Right.
We were taking the best people from the district offices and the division and trying to all come together and run that. And we kind of finally came to the conclusion, and I said, we did develop, for example, 4 different ways to run the gravity on just the fine aggregate.
Wow.
And we still couldn't get that the
variability
down. So we kind of came to the point and said, we don't want to implement a specification when we can't, when you and I can't get the same result.
Right. That's a key thing.
So we started looking at
reproducibility of the test result.
Right.
Yeah. Yeah.
So then we started looking at using the rice gravity, which includes a VMA. And what we find out is that, and if you've been around hot mix for very long, you find out that rice gravity is the most precise, accurate test that we run. I mean, as far as repeatable. If you take 100 people and you run rice gravity test, you get a pretty good variability. I mean, pretty low variability in that test. So we decided we're just going to use the rice gravity, and we're going to do it incorrectly, but precise. But we're all going to get the same number. We're all going to get the same wrong number. And then to adjust for that, we said, okay, we know that we're accounting for the absorbed asphalt in there. So Texas, we raised our VMA specification 0.5% above what all the national specifications were.
Okay.
So we said, okay, instead of a 15, we'll be 15.5.
Okay.
So we just raised that value and said we'd rather be wrong and repeatable than technically correct and
not repeatable.
and have to run referee test all the time, which we didn't want to be doing that all the time.
Because you would be.
And so it just stuck, and we, over the years, I think it's probably gotten better. Now there's certification schools, and everybody can learn how to do these tests the same way. But back then, we really didn't have that, and so it's probably gotten better doing it the other way. But at this point, TxDOT's had that spec for 30 years now, and so it's like, well, we know
it's working.
Yeah,
it's working.
It works.
I mean, nothing's perfect, but it's working. So I think that's important to understand. When we're looking at things, is there's a decision behind there's a rationale behind every decision, right? And so whether you like it or not, I mean, any agency is not going to just willy-nilly just say, okay, it's 7. Without having some data to back it up. And I think there was a logical decision that was made, like what you just said. We've got to be able to have repeatable results. And if we can't, we're going to have chaos. Yeah. Right? Because now you've switched over. Now contractors are running it. Now it's not just TxDOT running it. Now you've got contractors running it. So your pool of people now running this test is different. Yeah. And so we've got to be able to adjust for that. So I can, from the position at the time, I can understand the decision. I mean, some states would just set, they from a particular quarry, instead of running it every time, would just set a gravity.
Right. Yeah.
And they may change it from time to time. And obviously, if you've ever been to a quarry, you look at the face, and it ain't all the same stuff.
Right. Yeah.
And so, they would have to maybe adjust that from time to time. But that's another way of doing it.
Right.
I mean, and then some states would, say a purist, if you will, has to go through that.
Yeah.
But inevitably, they're going to have the same issue that Texas has. Is like, if I run it and you run it, and my aggregate gravity is off, guess what? My VMAs are going to be off. Mm-hmm. And so now we're having arguments or referees or that sort of stuff. We're back to square one.
Yeah.
And have we done anything? And then so we to me it makes sense that why the decision was made to deal with it the way they did, to say, hey, we'd rather have a number than a number we can trust than a number that we don't have any idea, even if it's a good number or not.
Yeah.
So good.
It's interesting to kind of. You think about for hot mix, we went through the same thing with hot mix. You think about when we first started measuring density of a specimen, you figure out, okay, if I dunk it in the tank and, do I leave it for 2 minutes, 3 minutes? How long do I leave it? Take it out. And if I want to get a better density, anybody that's been around it said, sling it off, get some of that water out of there, because you're determining the SSD at that point too, where you're patting it dry.
Right.
So if you use a dry towel,
how wet is your towel?
Exactly.
And how much do you roll it? and that's why they have the certification now to try to, alleviate that as much as possible. Now if you go to TxDOT, they got a robot that was developed at A&M that does it. But I mean, it's more kind of demonstration. It's not being used for production, but there's always variability, and we've talked about that in some of the other classes. There's variability in the sampling. There's variability in the testing, and there's variability in the materials. What we're really trying to measure is the variability of the materials, but sometimes the sample and the test variability can overshadow what we're really trying to measure in the field. And so that's part of one of the things that we're constantly working on from industry side and TxDOT side. How can we minimize variability? We're going through that exact same thing right now with this new balanced mix design. We've got new test procedures. How do we minimize variability? Well, how long is it cured? Oven curing, all these little things that you don't even think about make a big difference in the test result.
Right, yeah.
And so we've got to understand that. And as we develop the test result, the test procedure, there's a lot of steps. Well, every one of those steps is important. Mm-hmm. And that's why we don't want to I'm not going to skip step 5, 9, and 12 because it takes too long. Well, that impacts the test result. And so that's why we are precise like that, and that's why Texas has a certification program to make sure everybody's doing it the same way to minimize that variability, like you said just before. So we can, if the value of the mix is whatever it is, it's like, that's actually what's in there. It's not the way Jim ran the test because it was Friday and he wanted to go home. Right. Yeah. It is what it is. Same thing with the sampling. And TxDOT is just updating their sampling guidance, Text 222, and that's going to be coming out here in a month or so. Just some new ways of sampling to minimize variability, new ways of splitting the material out to minimize variability. That's all the effort to try to get back to what's in the core, if you will. So, anyway.
I think you bring up a really good discussion because you're right. There's the three things that and you want to cut down: sampling variability, the procedure, the material variability itself, because every material is variable, and then the technique or the procedure. The only thing that we were doing with the VMA, and I think the only thing you do have control over, and going back to the whole way we did the VMA, is when you add subjectivity into it, where it's a question of is this SSD or is this not SSD, you want to take all of that out of the procedure if you can, and that's even like I said, the way we dry cores now or dry molded specimens, you want that to not be subjective. You want everybody to do it the exact same way to get the exact same number, and so you don't want to add a fourth variable in there, which is just subjectivity on whether you're talking about ride quality measurement or anything. Sure. You want a set measurement. You don't want to be able to say, I think that was smooth, or I think this.
I think it's okay.
Your butt doesn't think that was as smooth as
my truck versus your car. Right. Yeah. So they're going to ride different.
Take out subjectivity and bias. You want to do that out of any test.
And I think that going back to the test procedures, that's why, the whole thing is. I mean, that was changed a couple years ago. Is when you put the sample underwater. Mm-hmm. It's not a minimum. It's within this period. Yeah. I mean, it's plus or minus X amount of seconds. Right. Yeah. Because they know outside of that, then I can get either more absorption or less absorption, and that can impact the test results. So every one of these items, and I just want to kind of go back and hit that one more time, is if you're in a lab or watching a lab or we want to do that, if we've got a result, we always want to make sure we're doing the test right. And again, if Jim's running it and Jim's not certified to run the test, so I could run the test. I've run the test before, but I'm not certified. And so we want to make sure we got certified people running the test on properly calibrated equipment, and everybody's, doing the calculations right and everything's good to go. So we can really rely on what the test results are.
And that's where we have proficiency programs every year just to verify. Let's all test it. And
you get a box of material, I get a box of material. I don't know what it is. You don't know what it is. We run it. We send the results in, and then they calculate the standard deviations and figure out where you're at. And hopefully you're in one of the lower standard deviations, right? Not out here on the fringe. So you mentioned ride quality. So you were involved in that as well.
Very involved in ride quality because back then we had the California profilograph was the first one. We used to have just 10-foot straight edge was was everything that we did.
Did you have the wheels on it? Or just
no,
just a
not
flat
not
straight
the
edge?
original, just the original. When I first started in the industry,
You had to
just
push
10
your
foot
straight
straight
edge
edge
down the road?
No, I mean they just had it in the back of the truck, and that's the only thing you measured was it had to.
Okay.
You know, there was a spec
Not-
that it couldn't have
More than a
so much
quarter or
variability
3/8 or
into
something like
yeah.
Yeah.
And so and just going back to the first project I ever did, and I remember the one in Abilene. At the end of that project, I remember that. And I always tell people the story. The chief inspector and I drove over that project at the very end, and he said, this project turned out pretty good. He goes, the only thing wrong with this is the ride quality is terrible. He said, other than ride quality, it's a good project. And then looking back, and you think,
Well, wait
ride
a
quality
second.
really is, and I look at it and say, well, the first project I ever did was probably a big failure because we had a lot of segregation. We had a paver stopped all the time. We dumped the wing, the contractor or producer, that was just normal back then.
It was the norm.
Run
Yeah.
as fast as you can, dump the wings every time, you at the end dumps. And
Zero pump, zero pump, zero
so
pump
ride
down the
quality
road.
was kind of an afterthought. So even in the early 90s, TxDOT only specified ride quality on a very few jobs when they started doing the profilograph.
Okay.
And then the push behind, so we had that part
That
of the
was a
certification.
25-foot metal
Yeah.
frame, or like a triangular
truss,
shaped
yeah.
thing that you had to assemble, put together, line up, calibrate, and then that literally would get walked down the road.
Right, yeah.
Did they do both wheel paths or one?
Yeah, they did both wheel paths then, I think. I'm trying to remember. It kind of brings back some bad memories of some of that because
Try to forget some of that
That
stuff.
was the worst job to have. But for one of the things is that TxDOT tended, because it was so cumbersome, TxDOT didn't only specify it on, very rarely. It was only on a few projects.
On the high
It was
profile jobs,
very
right.
high profile projects. But when the profilometers or the inertial profilers came along, and that's where I really got involved, was
Okay.
helping.
When was that? Do you remember roughly?
This was all in the mid-90s
Yeah,
too.
okay.
Because I was
Okay.
involved in getting the first, and I'm trying to think it was the 94 spec or it might have been the 2004, the 93 is the first time that we really put. Some of these we had special provisions, special specs
Sure,
came along
sure.
in between time, but we got it put into where we had ride quality on every job, and that was a big push.
I imagine that's some gnashing of the teeth.
And I don't want to brag on myself, but that was one of my deals was
Okay.
we should have ride quality on every job. The default should be you have a ride quality measurement on every job, and then write it out if you have a reason to write it out and go to
Right.
just to the 10-foot straight edge.
If you got
because back then, like I said,
2,500 manholes, it's probably
Yeah.
not going to ride very good.
and we built a lot of pavements. We got some really good pavements, but we also got some that were just, they were rougher than what they started with. And it's like, that's not the traveling public judges asphalt pavements or any pavements
Any
by the
pavement.
ride quality.
Yeah,
And so
absolutely.
we started finally, I think we were one of the first states, I think, that put that in on all specifications. And so that was,
Yep.
so the first pay schedules and all of that, people can blame me for that, and the guide schedule for the ride quality, I wrote all of that stuff. So I was
So you're on the
in the middle of a bunch of controversial things.
on the leading edge or the bleeding edge, maybe.
Yeah,
depending
yeah,
on how
so-
you interpret it.
Yeah. But looking back at it, I think we've come a long way, and I'm kind of I'm glad some of the things we went through back then was ride quality needed to improve because, and then on the rutting side, you go back to we addressed that. We were big push to the Hamburg wheel test on that side to address the rutting. So
Okay. So you were involved in. I mean, I agree on the ride thing. Is like that's the one thing I noticed when I drive. I just was driving yesterday for 3-4 hours. That you don't notice smoothness, but you notice roughness.
right, yeah,
Right? When the road is smooth, it's like you don't think about it. But when you're having to put two hands on the steering wheel, which you probably should have two hands on the steering wheel anyway, but when you're really having like, holy cow, what's going on here? You really notice that. And so that's something that we as an industry, everybody, right, needs to be focusing on is giving people a good smooth ride because not only does it help the people driving, but it actually helps the pavement last longer.
right, yeah.
And so I know you guys were involved in that as well. So okay, so you're the guy. All right, so now I know who to blame. No, I mean again, because I think
Probably to blame for a lot of it.
again Texas was kind of on the leading edge of that, and again, and then being in another state at that time, they're going, well, Texas is doing it. It's like, well, then it's like, well, I guess if Texas can do it, we probably can figure it out, you know. And so we went through that whole thing. It took a long time when we had the ride specs in there, and they went from a rolling straight edge, like a 15-foot rolling straight edge, to the profilometer version, and that was a big impact because what you're measuring is different.
Yeah.
And I think a lot of people never realize that is when you're measuring 15 feet, you're measuring bumps.
Yeah.
But when you're measuring a profilometer, the way that system works, you're measuring ride.
Yeah, you're talking about inertial profilers.
Yeah, inertial profilers. And so you're really measuring something that's different. And the contractors had to pave differently.
Right,
It forced them to do a lot of things differently in order to get that. They couldn't stop the paver all the time. They had to more continuous paving. The whole segregation stuff, the MTVs, all that sort of stuff were efforts to try to improve ride.
Yeah.
Minimize segregation, get better, longer lasting pavements, and which it did do and still does to this day.
Yeah.
And I think Texas was on the leading edge of the whole MTV thing as well.
Right.
So, good on you. I mean, we got good roads. So you also mentioned Hamburg. So we're getting back to the lab a little bit. So the Hamburg rut test, which is used to evaluate rutting potential of a pavement. So tell me about how that got involved.
Well,
How we got involved in that.
Yeah, so the early part on, so I mentioned we used to run a bunch of beam stabilities and a bunch of allotment tests. And what we found was we would have, part of my job in the flexible pavement section was to do forensic studies. And so very frustrated to go out and find out all these jobs that when we had rutting or stripping, and they all passed the initial specification. So they all passed going back to the beam stability, it didn't identify a lot of projects that were subject to, mixes that were subject to rutting. And the same thing with the allotment test. It just didn't screen out the bad actors very well. So this
Had
test.
a lot of variability.
Yeah, and a lot of variability, yeah.
Yeah, a lot of variability. So there you go, and
So
part of it.
And every test has variability. I think if you look at the statistics, most lab tests, if you can get a variability down to 20%, you're doing pretty good.
Yep.
There's some of them that I don't even want to tell you the numbers are,
they're bad.
because you'll shock out how high the variability is on a few of these things that are that we still use. But so that was, we started looking at along that time nationally there was some work looking at this Hamburg wheel test, and so we were one of the early adopters. Well, before that, let me back up. Even before that, going back into the mid-90s, looking at there was a Georgia loaded wheel tester, and so that one was
It actually used an inflated tube that this thing ran on to kind of simulate the tire, and that's still, I mean, there was a point where some states went to Hamburg and some states went to the loaded wheel tester, and that's what they still use as their default rut test.
Yeah,
so
I'll give you some background on that.
Okay.
So we had both of them. So Texas bought we had the loaded wheel tester. Like I said, again, I'm used to calling it the asphalt pavement analyzer.
Asphalt pavement, there you go, APA.
Yeah, so that's is the technical name of it now. But then the early one was Georgia loaded wheel tester or whatever. And we went to Georgia and looked at what they were doing and all that. So, but everybody was trying to address rutting. And even when Superpave came along, Superpave really didn't have a rutting test. There was nothing that in the evaluation of it identified.
You weren't breaking the sample or
or
getting a strength measurement of any means.
So we started testing. We started requiring all the districts to send in samples, and we started running Hamburg wheel test on every sample that was done in the state. And we were trying to do the loaded wheel tester, the APA, and we probably would have been an APA state if the APA had. It just wasn't the machine itself that wasn't very durable. So we spent more time working on the machine than we did. I mean, the mix outlasted the machine. So usually the samples, so we just couldn't run enough samples. It just was not robust enough to run a bunch of number of samples through it. So we were always working on them. So the machine was down half the time. So the Hamburg wheel test is like, okay, this runs So, but interestingly, when the Hamburg wheel test first came out, you had to have this big slab compactor.
Right.
And
right.
so the original
right.
part, so Texas was the first state that I know of, then I think we developed that in our lab, one of our technicians, of taking the molded Superpave specimens and cutting off the ends of them, buttoning them together
Right.
so that we could run the
Oh,
Hamburg
okay.
wheel test. And so
Huge,
that,
huge time savings.
yeah, so Colorado was one of the early pioneers, but they were using the slabs, and we got the slab compactor and all that, and basically found out this is just not practical for us to use in Texas, so we kind of found a way around it. And actually Byron Kneifel, that worked in the flexible pavement slab, or we called bituminous lab back then, came up with that way of making the mold and butting those together.
Yeah, trimming the little edge off.
And now that's what everybody does,
Yeah.
the universities
It
and
is
all
so
that, when they're
standard.
doing research, everybody's cutting off the samples and buttoning
Well,
them
you
together.
got them. What
Yeah.
else are you going to do with them? I
Yeah.
mean, so it just makes sense. It's not,
So-
you're not, and the amount of material and the effort to make a slab was,
Yeah.
uh,
So that innovation came from TxDOT, and I said one of our
That's
lab
cool.
techs is like, hey,
That's
how could we
cool.
do this easier? And it's like, okay, Byron came up with that, and so.
well, good deal.
But I guess to say all that by the 2000 late 90s and early 2000, we started implementing. So we got a big database on all the Hamburg, and what we found out was all of the tests that, and I looked at hundreds and hundreds of results and found out, and from these forensic studies, all of those that had rutting, when we go back and we'd run those samples to the Hamburg wheel test, it identified those as being susceptible to rutting.
well, that's awesome.
And so
yeah.
So we end up implementing that in late 90s, early 2000, and by the 2004 spec book, it was the standard in Texas, and so. And now you see that used in a lot of states. So, and I would say, just a general comment, rutting is not, rutting now is kind of almost exception. You'll see some of it, but not like
Yeah.
you did in the 70s and
it
80s.
is
It was
the minimum,
everywhere.
yeah.
Now it's like, we're trying to solve cracking problems now
Right.
in the state of Texas.
We're tweaking.
Yeah,
We're
we know
tweaking.
how to resolve rutting problems. So.
Well, good deal. I knew we were going to run on time, but I wanted to cover a couple of things real quick. When you went back to PaveTex and then it became Atlas, you did a lot of mixed design stuff. I just want to take a couple minutes and say, because you've looked probably looked at more materials than probably most people that have done designs. And so, what did you learn about that from that perspective?
I had an interesting challenge because over those 10 years I was working as a consultant, probably designed 300 to 400 mixes, and these are from all across the state. So there's a lot of challenges, but I guess just general comments is that, people are going to use the local materials that they have, and that's just the way it is.
Sure,
So when
as
a
much as
contractor,
possible, yeah.
So I did a lot of designs for producers and contractors, and so just the use of local materials. The contractor would send me the materials and say, here's the 4 or 5 stockpiles you have, and that's really what you have to work with. So regardless of whether you design it Superpave or Marshall or Beam Stability or whatever, you've only got certain aggregates and you've got certain asphalt to work with. And so trying to make that all fit together was a big challenge. So I learned a lot about mixes and mix designs, and a lot of the, I'm going to call it cheat codes, and a lot of things you just figure out about over the time of what's important and what's not important. But it may sound strange to hear this. I think we actually overemphasize the laboratory mix design side of it, because I think the one thing that people don't, and that may sound weird saying that, but I think that's really just, the mix design is just to give you a starting point in the field to adjust from. So, and another example is back, and I don't know if they still do it, but Louisiana used to just do plant designs. They just fire up the plant, produce
Run
a
the
mix.
mix and
If that
test
meets
it.
a spec, then you test it, and that becomes your mix design. Well, a lot of people get really hung up on trying to match a mix design to what's produced in the field. They're never, ever the same.
Yeah.
And it's just, so you need a mix design to know where to start from so that you don't waste a lot of time. But at the same time, you realize it's just a paperwork exercise to get you to the starting point.
Get you to trial
and
batch.
you got to trial batch and make those adjustments in the field. And
That's a
with
good
Yeah.
a good thing. So, what did you learn in the? I mean, now you're a couple 3 years into the Lime Group, so you're the executive director there. Congratulations again. What have you learned so far there that you didn't know?
You can't build good pavements on crappy subgrades. So
Good. Amen.
And
Amen, brother. Amen.
So it all starts with, we put a lot of emphasis in the Hot Mix Association on the hot mix. The
Yep.
concrete people put a lot of emphasis on the concrete. Generally speaking, people don't spend enough time on the subgrade design and the subgrade and the base. And those really should be designed for 500-year designs. They shouldn't
Yeah.
be on the subgrade. There's no
Yeah.
reason. But so a lot of the forensic studies that I did at TxDOT and that TxDOT still does, when you see things go wrong, very, very often it goes back to decisions that were made 50, 75, 20 years ago by someone that decided that didn't address, the issue. And so on the lime side, when you're dealing particularly with clay soils, which we have a lot of them in Texas, and they're all along that I-35 corridor and going
Yeah,
east.
going east.
That's where 90%.
All the way to Mississippi.
Yeah, 90% of the people live east of the I-35 corridor and that way, or right along that corridor and east, and that's where most of the people live. Most of the construction is on. A lot of it's on top of very poor subgrades, and so if you don't address that at the very beginning, you don't have a chance to build a good, whether it's flexible pavement, rigid pavement or not. It's
Gotcha.
just that. It just really goes down to, used to think that you could solve everything with a better mix or more base material. You can't. If you
No.
got poor subgrade and you don't address it, it's going to bite you in the butt
Yeah.
at
We-
some
we
point,
see
or the
that.
next generation, or the next
Yeah, we
generation.
see that all
after
the
you.
time. I mean, you're seeing the pavements move feet, literally feet.
Mm-hmm.
The pavement's moving more than the thickness of the pavement, so it ain't the pavement.
Right,
So
yeah.
there's issues out there.
Yeah,
So,
so-
couple more things here. I know we maybe need to do a part 2 of this and come back. We can certainly do that. What do we need to always remember about designing and constructing asphalt pavements from that perspective?
Well, I always go.
Other than including what's underneath. It's flexible. It's the whole system, right?
Yeah.
But anything specific to designing and constructing asphalt pavements?
So it always, to me, always boils down to the big three things. You got to have it to get any good project. You have to have a good design. You got to get good materials and good construction. So,
Okay.
so the design,
Okay.
so it's always the three-legged stool, and if any one of those legs is not there, so you can design a perfect pavement, and if you don't have good materials, you're not going to get a good job. If you have the perfect materials, the perfect design, and you do poor construction practices on it, or don't inspect it and test it, then you're not going to get a good job. So it always boils down to really focusing on those three things to make sure
Materials,
you
design, construction, and then you got to maintain it, right?
Yeah, and then
Which
maintain it over
is all
time.
about what Apex is about. So,
Yeah.
good
The
deal.
other one I'd say that our biggest lesson I learned from TxDOT was there was a lot of frustration in the specifications that's like, okay, the contractor didn't do what we expected them to do.
Mm-hmm.
And I go back to, and I have a contractor explain it to me, and I always say this half as a joke, but half not as a joke. And contractor told me one time, he said, we don't do what's expected, we're going to do what's inspected. So by specification, we have to do what you tell us to do, but you get disappointed, but you didn't ask for us to do certain things. So you don't expect good ride quality if you don't ask for good ride quality.
Or don't
expect-
give the tools to do that.
Right, yeah,
Right.
and if it's not a requirement, then you probably shouldn't have the expectation. So,
Okay.
so I think a lot of people
Good.
say if you have poor specifications, in which I think over the years we looked back to a lot of holes in the TxDOT specification, said if we want good ride quality, we got to ask for it. If we want good densities, we got to ask for it. If we want good QC/QA testing, consistent materials, we got to ask for
Yeah.
it. And so part of it is
Then the contractor knows
Yeah,
what
yeah.
to bid, and he can bid responsibly.
Yeah, and the other one is, the other one going back to that that goes along right with that is, if you expect it, you need to inspect it, okay? And then the other
Yep.
one is what gets measured gets done,
Yep.
and so if
Yep.
you're not measuring it, that's why we measure ride quality, we measure density, we take all of that. So it's kind of the big ones that always hit in my head is when I'm doing any kind of training for young people and things like that. It's very true with a lot of things in life. What gets measured gets done, and
Yep.
and so
Good deal. Good wisdom.
So,
Good wisdom. Okay. We typically ask people the last question, king for a day. You get to change anything. What is it and why?
man, try to make something. So I can't probably world peace and some
Well,
of those
you can
things.
no, you can
And-
change
and
anything
for everybody
you want.
to know God would not be on probably not as realistic, but
Well, we've had that. We've had people say that.
yeah. But so those would be good. But I say something more closer to. I think every dog should have the same lifespan as their owner. I think that
There
was
you go.
So
There you go.
I've been a dog owner my whole life, and it said it's always unfair to me that dogs live 10 or 15 years, and you have man's best friend should live as long as man. That's just me. So
Well, they spend
I'm
their
a
whole
dog
life
guy.
living for you.
Yeah.
And so there's something.
Yeah, so that's
yeah,
one thing.
I'm a big dog guy too.
If I
so.
could change something, I'd say a dog should, dog and their owner should live the same age. So.
Here we go. Good deal. Buddy, thanks. So that's all the time we have. Maybe we'll come back and do a part 2 sometime and continue on the discussion, but we try to keep these things in a reasonable period. So that's all we've got today. Remember, third Thursday of the month, 3 o'clock is when these things air. These are posted on the YouTube site, TxAppa's YouTube site, and apextex.org website or YouTube site. Remember, these also go up on the audio versions of most of the platforms that are out there now, particularly Spotify, Apple Podcast, etc. So, like, subscribe, and share. We'd appreciate that. And we'll see you next time on Everyday Asphalt. Ever forward, everybody. Take care.